Example 3, we're looking at a rotation of axes for a parabola. So we're going to rotate the axes to eliminate the xy term in the equation x squared minus 4xy plus 4y squared plus 5 square root of 5y plus 1 equals 0. Then we write the equation in the standard form and sketch its graph. So we want to, again, identify our a, b, and c. So remember, a is this coefficient here, so a equals 1, b is negative 4, and c is a positive 4. So remember, cotangent of 2 theta is a minus c over b. So we're looking at 1 minus 4 over negative 4. So we're looking at negative 3 over negative 4, or cotangent of 2 theta is 3 over 4. Now this looks a little different than what we did previously. So before we had something like 1 over root 3, and then we could evaluate it. So at this point it's 3 over 4, so it's not something that, the value becomes very easy to our mind about what it is on the unit circle. And so let's use what we know about right triangles. So cotangent, we remember, is x over y, or adjacent over the opposite. So if this is 2 theta, then adjacent is 3 down here, opposite is 4 here. Then let's find this value here. So this is going to be, c is the square root of 3 squared plus 4 squared, and that is 9 plus 16, which is the square root of 25. So we're looking at this is 5. Now we need to find our x and our y. And so, or our sine and our cosine. And so what we're going to use is our half angle formulas. So for our half angle formulas, we have sine of theta equals the square root of 1 minus cosine of theta, cosine of 2 theta, over 2. And then we have cosine of theta equals the square root of 1 plus cosine of 2 theta over 2. So that's the whole reason why we had to find this information. So now we can use cosine of 2 theta equals 3 adjacent over hypotenuse. So this is going to be 3 over 5. So now we can use that to plug into here and find sine of theta and cosine of theta. So this is going to be the square root of 1 minus 3/5 all over 2. And then, so we'll finish this out. So this one changes to really a 5 over 5. So the square root of 5 minus 3 is 2 over 5 over 2. And then let's simplify that. So this is 2 over 5 times 1 over 2. So we're really looking at the square root of 1 over 5, or simplified sine of theta equals 1 over root 5. Cosine of theta, we do the same thing. Square root of 1 plus 3 over 5, all over 2. And then this becomes a 5 over 5. So we're looking at the square root of 8 over 5 over 2. And then if we multiply, simplify, 8 divided by 5 times 1/2, we're really looking at square root of 4 over 5, or cosine of theta equals 2 over square root of 5. So now that we have that information, we're going to substitute like we did previously. So use substitution. And we're going to substitute it into our x equals x prime cosine theta minus y prime sine of theta. And then, of course, we're going to do the same thing with our y value. Y equals x prime sine of theta plus y prime of cosine of theta. So now we can plug in our sine and cosine to each of these to get our x's, so just like we did before. So let's do that. So this is going to be x prime cosine is 2 over root 5 minus y prime of sine of theta, which is 1 over square root of 5. So therefore, x simplifies to 2x prime minus y prime over square root of 5. For the y, this is going to be x prime times 1 over root 5 plus y prime times 2 over root 5. So now we know that y equals x prime plus 2y prime over square root of 5. So I hope you remember what we did before, is we take this and we plug it in to the original. So let's do that. So we plug it in to the original all the way up here. So x squared, so this is going to be 2x prime minus y prime over root 5, and that is squared. And then minus 4 times x times y. So 4 times 2x prime minus y prime over root 5 times y, which is x prime plus 2y prime over root 5. And then plus 4, and then y squared. So that is going to be x prime plus 2y prime over root 5. Then we have our 5 plus 5 plus square root of 5 times our y. Our y is x prime plus 2y prime over root 5. And then plus 1 equals 0. So just to save a little bit of time, and for you to go ahead and do the algebra in this, go ahead and multiply this out, and then simplify, and then I'll have the answer for you in a minute. So maybe you've gotten to this far, maybe you went a little bit further, but just to kind of pause and show you where you should be. So you're squaring this value here, so knowing the pattern is very helpful. And so you would get 4x prime squared minus 4x prime y prime plus y prime squared all over square root of 5 squared, which is 5. And then negative 4, you multiply these two together, these two terms, and so you get negative 4 times 2x prime squared plus 3x prime y prime minus 2 times y prime squared all over 5. Then you multiply this, you square this inside, so that's 4 times x prime squared plus 4x prime y prime plus 4 prime squared over 5. And then this last part, the root 5 cancels, and so this is plus 5x prime plus 10y prime plus 1. Then you distribute the 4 for both of these here, and so it simplifies a little bit further here. It's helpful to combine like terms with these two. So you have, for this one, it's negative 8x prime squared minus 12x prime y prime plus 8y prime squared. And this one changes to 4x prime squared plus 16x prime y prime plus 16y prime squared. And now let's combine like terms. So we have 4x prime squared, so let's combine our x prime squared. So we have 4 plus 4 is 8 minus 8. Well, look at that. The x prime squareds cancel. Then let's look at our x prime y prime here. And so negative 4 minus 12 is negative 16. So negative 16 plus 16, look, that goes away as well. Now let's look at our y squared. We have y squared plus 8y squared plus 16. So that's 9 plus 16y squared. That is 25 y prime squared, and that's all over 5. Then we have our plus 5x prime plus 10y prime plus 1 equals 0. Now continuing on, let's simplify this a little bit more. We have 5y prime squared. I'm going to rewrite this. So I'm going to write my y next to the y, 10y prime plus 5x prime plus 1 equals 0. So let's go ahead and move the x and the 1 to the other side. Okay, so now we're going to go ahead and complete the square. So get our standard form. So this is 5. Let's work with our y. So factor out of 5. And so we have y prime squared plus 2y prime. And then we're going to add something here. And let's go ahead and move the 5x to the other side and the 1 to the other side by subtracting. So we have negative 5x prime minus 1. And then we have to remember we're going to add 5 times whatever is the perfect number. So let's find the perfect number to complete the square, and that will be 1. And so we have 5 times y prime plus 1 to the square equals negative 5x prime minus 1 plus 5 is a positive 4. So let's go ahead and factor this right side. Let's divide a negative 5 out. So this right side is fine. So when we factor out a negative 5, we're left with x prime minus 4 over 5. Let's divide the 5 out. And so we find that the standard form of the parabola will be y prime plus 1 squared equals negative 1 times x prime minus 4 over 5. Now that's the standard form of the parabola. And so we know that our vertex in the xy system is 4 over 5 negative 1. Sorry, this is the vertex in the x prime, y prime system. So please watch the other videos so you can find the rotation of the axes, finding the vertex in the xy system, and then graphing.